Hi all, welcome to new class. Today's class is about star delta transformation. So this is the continuation of network theorems. So next is star delta transformation, and this star delta transformation is useful in solving complex networks. And basically any three circuit elements like resistive, inductive or capacitive may be connected in two different ways. One is called the star connection and the other is called the delta connection. So this is star connection or Y connection, and that is delta connection. And these two circuits are equal if their respective resistances from the terminals AB, that is AB, BC and CA are equal. That is, if the resistance RAB in star connection and also in delta connection RAB are equal. Also RBC in star connection and RBC in delta connection are equal, and RAC in star connection and RAC in delta connection are equal, then these two circuits are said to be equal. And in star connection, RAB is equal to RA plus RB, RBC is equal to RB plus RC, RAC is equal to RA plus RC. And in delta connection, RAB is equal to, here RAB is R2 and R3 are series which is in parallel with R1, that is R2 plus R3 into R1 divided by R1 plus R2 plus R3, and also RBC is equal to R1 R3 in series and which is in parallel with R2, and RAC is R1 R2 in series which is in parallel with R3. Now equating these two equations, that is equating the resistances in star and delta connections and solving, we will get RA is equal to R1 R3 divided by R1 plus R2 plus R3. That is the resistances in star connection in terms of the resistances in delta connection. That is, if we connect the resistances in star connection and delta connection like this, that is, this is R1, then R2 and this is R3. So RA is equal to the resistances connected to this point are R1 and R3. So multiply these two, R1 into R3 divided by total resistance. Similarly, RB is equal to R1 into R2 divided by total resistance. Then RC is equal to R2 into R3 divided by total resistance. And similarly, if we want the resistances in delta connection from the star connection, then R1 is equal to, so this R1 is equal to the resistances connected to this point are RA and RB. So RA plus RB plus RA into RB divided by the other resistance RC. Similarly, R2, this resistance R2 is equal to RB plus RC plus RB into RC divided by RA. Then R3 is equal to RA plus RC plus RA into RC divided by the other resistance RB. So this is star to delta and also delta to star transformation technique. So in star to delta transformation, we have to find the values of R1, R2, R3, and in delta to star transformation, we have to find the values of RA, RB and RC. Problem, obtain the star connected equivalent for the delta connected circuit. So this is the given circuit. So this is a delta connected circuit, and this one we can redraw like this. So this is 13 ohm, 12 ohm and 14 ohm, and here we have to convert into star connected circuit. So let this be the equivalent star connected circuit. Let R1, R2 and R3 be the resistances for this star connected circuit. So here what is R1? R1 is equal to 12 into 13. So 12 and 13 are connected to R1 divided by total resistance 12 plus 13 plus 14, and that is equal to 4 ohms. Then what is R2? R2 is equal to 13 into 14 divided by total resistance is 39. So R2 is equal to 4.67 ohms. Then what is R3? R3 is 12 into 14 divided by 39, and that is equal to 4.31 ohms. So this is the new star connected equivalent circuit for this delta connected circuit. So this is 4 ohm, 4. Let us do another problem. Ohm, then 4.31 ohms. Obtain the delta connected equivalent for the star connected circuit. So this is the given circuit, and here this one. So this is the given circuit. So this is 10 ohm, 5 ohm and 20 ohm resistances. So to convert into delta connected circuit, so here there will be one resistance, here also one resistance, here also one resistance. Let R1, R2 and R3 be the resistances in delta connection. Then what is R1? R1 is, so R1 is connected to 5 ohm and 10 ohm. So we can write 5 plus 10 plus 5 into 10 divided by the other resistance is 20. And we will get 17.5 ohm. Then what is R2? R2 is equal to 5 plus 20 plus 5 into 20 divided by other resistance is 10, and that is equal to 35 ohms. Then R3. R3 is 10 plus 20 plus 10 into 20 divided by 5, and that is equal to 70 ohms. So these are the resistances equivalent in the delta connected circuit. So this is the equivalent delta connected circuit for the star connected circuit. So let us do another problem. Ohm, 35 ohm and 70 ohms. Determine the current delivered by the source in the network shown. So current from this source we have to find, and this is a complex network, and here we have to simplify using the star delta transformation. So here there is a star connection. So this 4 ohm, 8 ohm and 2 ohm are in star connection. First of all, convert this star into delta. So here we will get a delta. So and let R1, then R2 and R3 be the resistances in delta connection. Then what will be R1? R1 will be 4 plus 2 plus 4 into 2 divided by 8. That is R1 is equal to 4 plus 2 plus 4 into 2 divided by 8, and we will get 7 ohm. Then what is R2? R2. So this is R2. R2 is equal to 4 plus 8. 4 plus 8 plus 4 into 8 divided by 2. And we will get 28 ohm. Then R3 is equal to 2 plus 8 plus 2 into 8 divided by 4. And that is equal to 14 ohm. So now we can draw the circuit diagram. So it will be, so here 20 R2. R2 is 28 ohm. So here this is 28 ohm and here also 28 ohm. Then here there is source. Then here R1. R1 is 7 ohm and here R3. R3 is 14 ohm. Then here also 14 ohm and this is 3 by 4 ohm. So this is the new circuit diagram after converting to delta. So here 28 ohm and 28 ohm are in parallel. Also this 14 ohm and 14 ohm are in parallel. So when two equal resistances are in parallel, then we can take the half of the resistance. So here we will get 14 ohms and here we will get 7 ohm. So again redraw the circuit diagram. So this is the new circuit diagram, that is here we will get 14 ohms and here we will get 7 ohm and the 7 ohm and the 3 by 4 ohm and the 6 volt are there. Now let A and C be the 2 points. So we have to find the equivalent resistance between A and C. So here 14 ohm and 7 ohm are in series. So RAC is equal to 14 plus 7, which is in parallel with this 7 ohm. So we will get 21 into 7 divided by 21 plus 7 and that is equal to 5.25 ohms. So this is the new circuit diagram. Now we can find the current from the source. So I is equal to V divided by total resistance, that is 5.25 plus 3 by 4 and we will get 1 ampere source. So that is about the value of current from the transformation. Let us do more problems related to star delta transformation in the next class. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.